Good morning, students. So today we are going to solve question 27 from GATE CSE 2024 set 1. The question states that let A and B be two events in a probability space with PA is equal to 0.3, PB is equal to 0.5 and PA intersection B is equal to 0.1. Which one of the following statements is R true? Is R means that this is a multiple select type question. That is, multiple choices can be correct and we have to select all the true choices, all the correct choices, right? Now, what the information of the question I have enlisted like this. This is the given part of the question, that P of A is equal to 0.3, P of B 0.5, P of A intersection B 0.1, right? This given part we will use throughout the question. Now, the first option tells us that two events A and B are independent, right? So, are A and B independent given this information? Let's see. So, first of all, let me try to explain to you the concept of independence and how we are going to check for it, right? So, at least what we have read in 11th and 12th classes is that there is a concept of event A occurring, given that another event B has already occurred, right? We express it like this, given a probability of A given B, right? So, this concept means that right now I'm expressing this like this, right? This whole rectangle represents a probability space. That is, inside of this there is a probability of both A occurring and B occurring. But if B is fixed as the probability space, then this rectangle collapses down to the area of B only, as I've expressed over here, right? So inside of this B there is a portion of A also, right? So this portion of A inside of B is what is known as P of A given B, right? And this region is equivalent, as you can observe, to what is PA intersection B, at least in bare magnitude, right? In bare magnitude, not in absolute magnitude, because now the probability space has collapsed, so we have to calculate its new probability which exists inside as a ratio of this new probability space, right? So let me express that. So P of A given B, that is this region in the new probability space written here, is equals to P of A intersection B. This is from the old probability space getting here, and this part taking what is the ratio of this part in this whole part. We get the whole ratio here, which is equal to this thing. This is what is known as the concept of Bayes theorem, right? You must have read this in your 11th and 12th. If you have not read this, if you have forgotten this, let this be a reminder. There is nothing wrong in forgetting, that we must keep ourselves reminding ourselves and learning, right? The whole point of this channel is to inspire others to learn, right? So now once we know the concept of Bayes theorem, we can understand the concept of independent events. Independent events are basically independent event concept basically means that A and B are independent. That is, if B occurs, the probability of A will remain the same. If A occurs, then probability of B will remain the same. That is what the concept of independence is, right? Here I'm showing that B has occurred, right? This is A, P of A given B. So this region will take as much portion of this whole B as this circle is taking of this whole probability space. That is the concept of independence, right? So P of A given B is equals to P of A. That is the concept of independence, right? Let us take this whole thing together. Let us take this, because this part P of A is equal to this thing and this thing is equal to this thing. So we can take P of B to the left hand side, and we have P of A intersection B is equals to P of B times P of A, which can again be expressed like this. And this is an identity, which not an identity, this is a condition that we check for independence. This is a condition that we check for independence of events A and B, right? So now once we have the exact formula, you must have already read this formula. I'm just explaining it again to you so that you are revised on the concept, so that even if you forget in the examination what was the formula, okay, I can reduce it like this, and from that we can directly apply the given portion of the question. I have again copied the given portion, that P of A is equal to this thing and all this. So let's apply it to the LHS. LHS is directly application of the value of in A intersection B, that is 0.1. RHS is given as this thing, right? We can then write that the P of A is equal to 0.3 times your 0.5 is going to give you 0.15, right? And this thing is not equals to your LHS, hence your condition for independence is not met. So this statement is false. This statement is false. So we can directly write that the truth value of this statement is false. The truth value of this statement is false. Now the second statement, B statement. It states that A union B is equals to 0.7. Let's solve for that. Let's solve for that. I've written the option here once again. Now suppose that this is your again probability space. This is your A event and this is your B event. Ignore this part for now, right? Ignore this part for now, right? So let me do it like this, right? This is the exact diagram, right? So this portion is your A, this portion is your B, this portion is A intersection B, right? So PA union B, at least in magnitude, is going to be equal to what? P of A, this whole region, plus P of B, this whole this whole region, right? But see, when we overlap this area, this region, right? This region is coming twice, in here also, in here also, right? So we must subtract that part. We must subtract that part to make it accurate, right? Once we do this, we get this formula which we actually use. This is a set theory based formula that you must have seen in different forms, one form or the other, and it's very well known identity, right? Now we can express it like in a formal manner here, and then we can apply the values that are given in the question and then check is the value of A union B actually 0.7. So let's do that. Why not? Let's do that. So RHS is going to be equal to P of A is given as 0.3, P of B is given as 0.5, and P of A intersection B is given as 0.1. So this is 0.8 minus 0.1, which is going to give you 0.7, right? And that is exactly the value that is given in the option B. So option B is actually true. Wonderful. So we now know that the truth value of B is true, right? Now let's see the option C, right? Option C states that P of A intersection B complement is equals to 0.2, where P of BC is the complement of B. Okay, so let me explain to you a very important concept, right? This is a direct part which is given to us, and if you think about it directly, you will be thinking, how can I find it, right? So whenever you have any confusion or anything in, at least in probability or in probability concept, draw a Venn diagram. That is the best approach. And the more you draw Venn diagrams, the more your analytical power on this subject will increase. The point of solving question is to increase your analytical power on this subject, right? That is your aim. So draw Venn diagrams and try to understand it from that, right? So now I have P, this is a simple Venn diagram, this is A, this is B, and this is A intersection B part, right? This is whole part I have explained earlier also. Now B complement can be expressed like this, right? The portion of the rectangle that is outside of B is the B complement, and it is intersecting with A in this region. I have drawn this region outside here also, right? Now this region can be interpreted as the whole of A minus the intersection part of both of the A and B, right? So that is what I'm going to do. That is what I did here. This is also an identity of probability, right? So I think that you're able to understand this much, man. If you're not able to understand this, comment this in the chat, and I will explain it again in the chat also, right? It's a very simple concept. Now I can, once I have the formula, I can directly apply the values and check whether A intersection B complement is actually valid, right? And has the value 0.2. Okay, so let's do that. We have P of A is given as 0.3 minus P of A intersection B is given as 0.1, which is going to give you 0.2, right? And that is exactly the value which is given to us right over here. So this particular option is actually true. Okay, so we know that the truth value of this option is true. Now the fourth option, A complement intersection B complement is equals to 0.4, where A complement B complement are A raised to power C, B raised to power C, as it is read from us, is basically the complements of both of them. Okay, so now we have to check for this value. Let's do that over also, right? So A intersection, no, not this one, right? So how can we find this value now, right? So if you know, there is the concept of De Morgan's theorem, right? De Morgan's theorem, right? You can read about it on the internet also. I'm going to explain how that works in a kind of a visual manner. It's a very simple manner. Actually, you must have seen teachers do it before also, but this is just a reminder if you have already studied, and this is actual demonstration if you are studying it for the first time, right? So now let's understand that concept of A complement, right? This circle is A, this circle is B. So no, sorry, this circle is A and this circle is B, and this circle is your okay, let me just do one thing. This is let me draw it like this. I don't know how I placed them in the wrong manner, but now they are correct. Now, so this is A as we are taking throughout this question, and this is B. That is the basic assumption. Now A complement is going to give the region of the rectangle outside of A, that is A complement. B complement is a region of this rectangle outside of B, right? We have A complement, B complement. Now if we want the intersection of the both, I can directly take this particular representation and put this on top of the first one, right? So as you can see, the overlappment of both of these regions are present outside of both of the circles. Inside the circle there is only one kind of pattern, not both of them being on top of one another, right? That is only happening outside of both of the circles, right? That is only happening outside of the both of the circles. And what is this pattern for? What is this pattern for, right? A union B whole complement is this pattern, right? And this is exactly the same pattern which we are getting from the intersection of A complement, B complement, that is here represented in this visual manner, right? So we got the answer actually, man. We got the answer actually, man. We got a very specific kind of thing here, that the real answer for our question, that P A complement intersection B complement is actually equals to the probability for P A union B whole complement. This is your basic answer. You can, if you're not able to understand this right now, pause the video and try to observe the patterns. We as humans can only comprehend patterns, right? So we must focus on patterns, try to understand how this and this are exactly the same, how we are getting this from complements and their intersection. Try to understand it. If you have any doubts, comment it down on the video. I will try to reply to your comments, and we all can have better understanding, right? We must develop better understanding so that we can all have fun on this world. Otherwise we can all just be sad. There is no point in that, right? So once we know that P of A union B whole complement is something that we have to find, right? So there is a identity in probability, which is P of A complement is equals to 1 minus P of A, right? This is an identity. This is an identity inside of your probability theory, right? And this is coming from set theory only, but obviously speaking, this is an identity that we use. We can use it here also. So, and from option B, which we have already shown has a truth value, of true, we know that P A union B is equal to 0.7, right? That's why I pasted that option here also. And we have to find its complement, this whole complement, right? So we're going to do 1 minus of that, right? Right? So this is what we're going to do. So let's do that. This is the given portion. So your value for P A union B whole complement is equals to 1 minus 0.7. The 0.7 is coming from here, option B, which we have already proven as true, right? Which is going to give you 0.3, right? Now 0.3 is not equals to 0.4, right? It is not equals to, this thing is not equals to 0.3. Hence this is actually false. So we know the truth value of the fourth option. The fourth option's truth value is false, right? So we know we have actually taken out the truth value for all the options. Now we can directly say the question is asking for the statements which are true. So we need to mention the options which are actually true. So that is going to be B, comma C, and that is your answer. I hope you understood something, you learned something new, and if you had not really learned anything new, you must have revised few of your concept. Making this video really did revise some of my concept, right? So I hope the same has happened to you, right? Other than that, if you like the video, like and subscribe. Thanks for watching. Have a nice day. Inspire others to learn things, man. That is the best way for us humans to basically make all of us happy, right? Okay, Ann. Okay, bye. Take care.